is you look at these boxes, which we call free body diagrams, and we're going to look at the vectors of force that are coming out of them and kind of determine what's going to happen. Now, if I have a force coming out this way, which is considerably longer vector than the force on the left side, my result is going to be a little bit of a box that ends up going to the right. Does that make sense? Because this one's going to kind of chop off a little bit of this one. All right, now here we go. In the up and down direction, if my downward vector is considerably larger, what is going to be the result of that? Well, you're going to end up with a net force acting in the downward direction, and guess what's going to happen? I'm going to accelerate in the downward direction, right? Now over here, we have a combination of vectors that are at right angles to one another, right? So what ends up happening here is they're not going to take away from each other at all, and instead you're going to end up with a vector that goes up and to the right. Okay, so up and to the right. Okay, so you end up with a vector that goes like that, right? So you're going to kind of go diagonally. Okay, so just kind of use your common sense to do some of these problems and see how you do. In the next couple days, we're going to add numbers to them, so be ready for that. Okay, here we're doing the guess method. So really we're going to use these equations. So the acceleration equations kind of rearranged, and then now we have force equations. Okay, acceleration is force net over mass. Mass is force net over acceleration. Force net is mass times acceleration. This is also how you calculate weight, force gravitational, right? So force is mass times the acceleration due to gravity, okay? All right, guess method. The car starts from rest. So from rest means velocity initial is 0. Accelerates at a rate of 2 meters per second squared. What will be its speed? Velocity final equals after 6 seconds of acceleration. Okay, so that's going to be, what is its speed? We are looking for a velocity final, or change in velocity right here, right? So I'm going to put this equation up on the board for y'all, so that way you don't have to think about it too much, but velocity is going to be acceleration times the amount of time, okay, our velocity final, if we're starting from rest. Okay, so let's go ahead and plug in our numbers. 2 times 6 seconds, so we end up with 12 meters per second is our velocity final. Okay, down here. Car starts from rest, that means velocity initial is 0. Accelerates to 2 meters per second squared, so here's our acceleration. How long will it take? That's a time equals question, right? To be going 14 meters per second, so that's our velocity final. So a how long question is our change in time. So that's this guy right here, okay? So let's go ahead and plug in our values. We have change in time equals change in velocity over acceleration. Okay, so that's going to be 14 minus 0 is just 14 over 2, and that's going to take 7 seconds. That's our time. Okay, now let's get into force problems here. Let's drag our equations down. All right. What is the force? Remember, force is measured in what? We'll figure that out in a second. You need to accelerate a 10 kilogram mass. I just told you what it is. The mass at 4 meters per second squared. That's our acceleration, FMA. Okay, what is our force? That's question mark force. Which equation is that? That's going to be, bam, right here. Force net is equal to mass times acceleration. Let's plug in our mass. 10 times 4. So that's 40, and we know that Isaac Newton did a lot of stuff with force, so he gets the unit. Newton, 40 newtons. Okay, the acceleration due to gravity on Venus is 5 meters per second squared. So this is our acceleration due to gravity on Venus. On Earth, do you remember what it was? Acceleration on Earth is 9.8 meters per second squared. Now, a lot of times in this class, we're going to just say it's about 10. Okay, about 10 meters per second squared. Okay. If your mass is 64 kilograms, so that's our mass, what is your weight? Remember, what's the other word for weight? Force gravitational, right? So force gravitational is a force, so we can multiply mass times acceleration. So let's go ahead and do that. Force gravity. You can plug in any force into this equation. Okay. Force gravity is mass times acceleration. Our mass is 64 kilograms, or my mass in particular, times 9.8. Nope. Why is it not 9.8? Because we are on Venus, not Earth. 5 meters per second squared. All right. So we're going to plug that in the calculator. 5 times 64. And we get 320. And what's the unit for force? newtons. All right, good luck, guys.